All right, and here we go. We're on the back of the notes. This is part 3. There's one more angle relationship that we're going to talk about today, and this is called the exterior angle theorem. All right, so let me read it, and then we'll draw a picture to represent what's going on. The measure of an exterior angle is equal to the sum of the measures of the two remote interior angles. So here's what the situation looks like. If we have a triangle, and we'll call this angle 1 and angle 2. Now I'm not going to put an angle 3 in yet, but I will eventually. If I extend one side, what it does is it creates another angle. I'm going to call that angle 4. Angle 4 is outside of the triangle, so we call that an exterior angle, which is just an outside angle. So that's exterior. Now 1 and 2 are interior, and so is, if I want to say, here's angle 3. Angle 3 is also interior. 1 and 2, though, are not next to angle 4. They are remote. Remote means kind of a far-off place, a distant place. 1 and 2 are away from angle 4, so we call angle 1 and angle 2, those are remote interior. Remote interior angles. Remote interior angles. All right, and what this relationship says is that angle 1 plus angle 2 equals angle 4. If you add up the remote interior angles, it has to equal the outside angle, angle 4, the exterior. Add up the remote interior, it's got to equal the measure of the exterior. So for example, if we look at number 6, there's actually two ways to do this. We're looking for x. This is outside the figure because we extended this bottom side. 52, 45. Now we don't know the third angle inside, the third interior, but we could find it. We could do 52 plus 45. You get 97. Now the total inside of the triangle is 180 degrees, so 180 minus 97, that's going to give you 83. So that's 83 right there. Now if you want to find x, well, the x and the 83, hey, they form a straight line. They are a linear pair, which means they are supplementary. These two angles have to add up to 180. So if this is 83, let me subtract that from 180, and what I get is 97. Now you're saying, well, wait a minute, we already got 97. That was from 52 plus 45. So you could use this rule that says that if you add up the remote interior, 52 plus 45, it's got to equal the exterior 97. So let's do example number 7 here. Now this time, here's my triangle. We've extended this side here. So 4x minus 10, that is your exterior angle. The two angles that are farther away from this are down here at the bottom. So what does the theorem say? If I take x plus 2x plus 20, if I add my remote interior, it has to equal my exterior angle. So what happens here is we get 3x plus 20 is equal to 4x minus 10. I'm going to subtract 3x from both sides, so we get 20 equals x minus 10, and if we add 10, we get 30 is equal to x. Now, it doesn't tell us to find anything else, so I think we're done at this point, but one thing that we probably want to do here, let's just take a look at this. If we plug it back in, does it make sense? If we take 30, then this angle on the left is 30 degrees. Now 2 times 30 plus 20 is 60 plus 20, that's 80. And then 4 times 30 minus 100, or minus 10, Is 120 minus 10? That's 110 degrees. 30 plus 80? Is that equal to 110? Yes, it is. So does this make sense? Yes. X is equal to 30. All right, the last one here. We'll take a look at number 8. It says a triangle has the given vertices. A triangle has the given vertices. Graph the triangle and classify it by its sides. Now again, classify means to give it a name. Then determine if it is a right triangle. All right, so we've got two things we want to do here. First thing, if they give us points, well, let's go ahead and draw a picture. So what I'm going to do here is draw a coordinate plane. All right, now let's see. We've got 3, 3, 6, 9, 6, negative 3. So we need to go out here. 1, 2, 3, 4, 5. We got to go out to 6 for the x. For the y-axis, we have to go to 9. 4, 5, 6, 7, 8, 9. I should have used a ruler. That would look better. 2, 4, 6, 8. This is 2, 4, 6. And then going down, we have to go to negative 3. And I'm just counting by 2's when I number the line. All right, so we've got 3, 3. So there's A. We've got 6, 9. There's B. And we have 6, negative 3. There's C. And the other thing I'll do here, I'm going to write down that's 3, 3. This is 6, 9. This is 6, negative 3. And then we can connect this, and what we have is a triangle. And we have some questions that we want to answer. First thing is to classify it. Classify it by the sides. So is it equilateral, isosceles, or scalene? Now you might look at this and you might have a pretty good idea right now what the answer is. Well, to justify it, to prove it, you've got to find the lengths of the sides. Now to find BC, that's actually the easiest one because that's a vertical line. We can just count. From negative 3 to 9, we would go up 1, 2, 3 to get to the x-axis, and then we would go up 9 more. So we go up 3 and 9, so this is 12. So BC is 12. Now, how do we find AB? Well, that's a diagonal kind of line, so we can't just count that, but we do have a formula that we could use to find length, or what we call distance. We have D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. So let's take for AB here. Okay, so I'm going to say distance and I'm going to put AB because I've got two things I need to find the distance for and I don't want to mix them up. So for AB, I'll make 3, 3, that's x1, y1, and then 6, 9 is x2, y2. So here's my x1, y1, here's my x2, y2. So we're going to do big square root. x2 minus x1 squared, 6 minus 3 squared plus y2 minus y1 squared, 9 minus 3, and that gives us 3 squared plus 6 squared. So 3 squared is 9, 6 squared is 45, or 36, excuse me, and 9 plus 36 is 45. So that's the square root of 45. Now, you could put this in the calculator, you could get a decimal for it. I'm just going to write square root of 45 for the length. Now notice I'm putting square root 45, I'm putting 12 outside the triangle. Why? Because those are not angles, they are sides. So I'm going to label the segments. Now the question is AC. You know, it kind of looks like it's the same as AB. Well, let's see if that's true. We'll do distance again. AC. Okay, equals Again, we'll have a square root. Now this time I'll do x1, y1, 3 comma 3 again, and I'll make this my x2, y2. So subtract the x's, 6 minus 3 squared, and then subtract the y's, negative 3 minus 3 squared. So that gives us 6 minus 3 is 3 squared plus negative 3 minus 3. That is negative 6 squared. Now I'm going to do this one on the calculator. When you, I got to set this up again. Technical difficulties. Okay. When I type this on the calculator, I've got to be real careful here. 3 squared is not a problem. Okay, when I do 3 squared, that's going to give me positive 9. Let me put it right there. Now when I square negative 6 though, I have to remember to put this in parentheses. A negative times a negative is a positive. And if I type it without the parentheses, I'm going to get the wrong answer. So I need to put that in parentheses. It's 9 plus 36, which actually gives us the same thing. We get the square root of 45. So what that tells us here is that these two sides are congruent. And if two sides are congruent, that's not the same as 12, but those two are congruent, then this must be isosceles. Okay, so there's our answer to that. Now, the last piece of this that they ask, so there's one answer. We classified it by the sides. Okay, so this is good. Now, how about determine if it is a right triangle? This is going to be a little bit easier. If it's a right triangle, the right angle would probably be here. How do you know if it's a right angle? Well, if it's a right angle, then that means BA and AC would have to be perpendicular. To be perpendicular means that the slopes would have to be opposite reciprocals. So what we'll do is we'll compare the slopes. So for AB, we would rise and we would run. Now if I count this from 3 to 9, I would rise 6, and then I would run. I would go from, let's see, 3 to 6. That would be 3. So we would rise 6, run 3. So the slope of AB is 6 over 3, which is 2 over 1. The slope of AC, so now this time we're going to go down 1, 2, 3, 4, 5, 6. So down 6, which is negative, and then we're going to run 1, 2, 3, which is positive. Negative 6 over 3 equals negative 2 over 1. Now these are opposites, positive, negative, but they're not reciprocals because we did not flip the fraction. So the answer is not a right triangle. And that is the end of the notes.